Okay, next up, we have our next speaker, Molly Jane Bennett. As you can see, I don't really know her. But seriously, wait, Molly, where do you work again?
Girl therapy?
No, wait, me too. Yeah, Molly is one of my favorite coworkers. Don't tell my manager. But I just love Molly so much. She's such a creative soul. I mean, look at the top that she made herself. Super cool, right? Yay! And my favorite thing about Molly is that she just chooses to have fun, everything that she does. I mean, look at this. This is how she manually QAs the video conferencing feature. But Molly is just a joy to have around, and I absolutely adore her. So you better listen to her talk, or else I will fight you. So give it up for Molly Jane Bennett.
Hey, everybody. Just getting situated here. Oh. Just bear with me one moment. All right, there we go. Yay! All right. Hey, everybody. Let me just see if I can get the clicker working also. Oh, beautiful. I'm so glad to be here. So not long after I learned to code, I got interested in making my own clothes. So I learned to sew and dabbled in some other fiber crafts. And here I am in the crooked yellow shirt, which is the very first one I made. And learning these skills kind of broke my brain open. Learning to code made me confront everything I believed about the limitations of my intelligence. And sewing taught me this whole new spatial language. And I've thought a lot about how differently these two skill sets are valued and who tends to do them around the world. So 60 to 80% of textile workers around the world are women, and they make, on average, 2 to 5 times less than the amount that would be needed for like a minimum livable wage in any given country. Meanwhile, we software engineers tend to be really highly paid, and about 8% globally of us are women, though that's higher in the US, about 28%. And coding and clothing production aren't just connected in my brain, where setting a sleeve is hard in the way that understanding a closure in JavaScript is hard. These fields have been interwoven, if you will, since the very beginning. So we have a lot of folks talking about AI tools, and my own experience of using GitHub Copilot is kind of like Josh said yesterday. It's like amazing at the things it's great at, including unit tests. So this is me writing a simple unit test for a functional React component. And as you can see, it's taking Copilot like less than a second to suggest something that, while not a huge lift, might have taken me a few minutes to write. So let's, and I'm sorry, Tyler, this is like a really low quality GIF, and I did have other options, I now know. So let's talk about how this is similar to this. So this is a Cartwright power loom, and it is, like Copilot, among a set of innovations that characterized a period of rapid automation of human labor. At the end of the 18th century, the wool trade employed 10% of Britain's population, and weavers in particular were the largest class of laborer. Now, prior to industrialization, people worked in their homes, in small shops, among their family members, and most weavers could make an excellent living wage working less than 30 hours a week. Now, cloth makers often improved the tools of their trade, making things more precise, faster, more efficient, like with the flying shuttle and the spinning jenny, and they all have like amazing names like this. And by the late 1700s, though, things were really changing. These technologies were being supercharged by the addition of hydro and steam power. So Richard Arkwright was an inventor who hooked up the spinning jenny to a giant water wheel, so that rather than employing the teams of women who had traditionally spun wool or cotton into yarn. He could do this around the clock in a factory staffed by totally unskilled children as young as 6, and most of them were orphans. Weaving, though, as opposed to spinning, was long thought to be way too complicated to ever be fully mechanized. But in the 1880s, a poet and clergyman named Edmund Cartwright visited Arkwright's factory, and he left determined to invent a machine that would revolutionize weaving in the same way. By 1785, he had patented a really horrible first version of this, but he and others continued to really rapidly iterate on it and improve on it until it was actually pretty good. And 25 years later, the cloth trades were being really disrupted by these new factories and sets of innovations. So also Britain was in an economic depression due to the Napoleonic Wars and a few years of bad harvests. And many workers in the countryside were facing starvation. Textile workers from the old cottage system were having a lot of trouble finding work as the market was just flooded with these cheap, often inferior fabric yardage and knitted stockings that were coming out of the factories. And they'd already made appeals to Parliament to help blunt the effects of factorization. They asked for retraining programs or taxation on technologies that eliminated skilled jobs, which are ideas we're still discussing today, by the way. But they hadn't seen any success in getting this. So enter the Luddites. If you've heard the term Luddite, it's probably been used as a pejorative, or maybe someone self-identifies that way, but it's very much against technology, against progress, fearing the future. I'd argue this is a pretty classic case of history being told by the winners, though, because the Luddite uprising was a labor movement, and it was comprised of textile workers and their allies. It began in 1811 in Nottingham, England, and it ended up spreading throughout the entire country. Working in autonomous, really tightly coordinated cells, the Luddites would break into factories and smash stocking frames and power looms with these giant sledgehammers. And they did this in this really targeted way. They would leave some machines untouched, but those that they deemed hurtful to commonality, those are the ones they crushed. So they also loved theatrics. Like they wore goatskin masks on raids or often would dress in drag. And the word Luddite comes from Ned Ludd, who was a probably fictional apprentice who was admonished by his master for knitting too loosely on a stocking frame. And then in retaliation, he smashed the master's frame. So this became kind of like the folk hero of the Luddite movement. And they would sign their list of demands and missives with the name General Ludd. And initially, they were really successful. They got local victories, like getting factory owners to agree to price thresholds for certain goods. And so they had this huge momentum initially. And it was this really big movement. In 1811 and 1812, they smashed thousands of machines. It was really broadly popular and hard to quash. The Crown deployed masses of troops, and the troops found a really hard time to even infiltrate the Luddites because they were in such tight, socially connected cells. Ultimately, though, 40 to 50 Luddites were killed either by hired factory guards or they were hanged by the Crown. Basically, they made machine breaking a capital offense. And the Luddites killed one person. Several Luddites assassinated a factory owner. And in the trial of these assassins, the major narrative that we know today of the Luddites was formed. The ruling class formed this narrative that Luddites were this brutish, angry, uneducated mob that was being inspired by infiltrators to go crazy and smash things. The public execution that followed that trial really marked the end of major Luddite activity in England, though smaller acts of disobedience continued for quite a while. And so broadly, the industrialists won that chapter. And in the wake of this, our own field of computing really emerged. Let's talk about another loom. This is a really cool loom. This is the jacquard loom. And this picture, this was silk weaving that was actually made on a jacquard loom. And a jacquard loom is for weaving intricate patterns into fabrics. And this is incredibly labor-intensive, expensive craft. And in 1804, Joseph Marie Jacquard patented this loom that used the punch card technology to basically determine a binary for a pattern. So there's a punch card and the weft thread. If there's a hole there, it's going to pass through and create the pattern. If there's not a hole, it doesn't pass through. So that's where we get really the inspiration for binary. And this was used by Charles Babbage and Ada Lovelace when they built the analytical engine, which is considered to be the predecessor to the modern computer. So they directly use that punch card technology to express mathematical programs. And I feel like the way that I've often read about Babbage and Lovelace and the project of the analytical engine is as this kind of like pure mathematical inquiry and innovation. But I feel like we don't talk a lot about what Babbage was actually trying to do, which was that he imagined computerizing entire factory systems so that there would be like no humans in sight. And he wrote this whole book about it. And a totally automated process with no people is something that we're still chasing. Amazon has announced but not yet achieved totally robot-staffed fulfillment centers. Then there was that recent controversy of the AI-powered store, which ended up not being AI at all, but actually a bunch of cameras and low-paid workers watching through them to determine what people were purchasing. So where does that leave us? Whenever Copilot writes a unit test really quickly or does something awesome, it delights me, but it also sends this little shiver of fear down my spine. Am I watching my own replacement? And I don't know the answer to that question, but I think it would be a good idea to remember a few lessons from the Luddites. 1, don't assume inevitability. In the time of the Luddites, the ideas of modern capitalism were very new, and no one knew exactly how it would play out. They defended their way of life as if it was fully possible to retain their power and autonomy as artisans. And while they weren't ultimately successful in stemming the tide of factorization, they slowed it down and they created a blueprint for later labor movements. So I don't know the future either. And assuming certain outcomes can make them self-fulfilling prophecies. It dulls curiosity and creative thinking, which leads me to 2. Protect your craft. And I think we have a lot of other people talking about this as well. As I mentioned, I love a good Copilot unit test, but I try to be mindful of when I'm using AI tools to speed up a familiar task and when it's preventing me from learning something new. Like right now, I'm trying to get more comfortable on the back end, and Copilot is like great at suggesting what might come next in a line of Python, but that doesn't mean that I'm going to understand it. So finally, ask who benefits. The history of industrialization teaches us that automation doesn't necessarily eliminate labor so much as it marginalizes it. Whether that's the orphans in Arkwright's factory or very low-paid workers working on the clothes you wear in Bangladesh. And this marginalization isn't as visible today as it was in the 1810s, when people could see the factory being built on the edge of town and watch the air darkening with coal smoke. We don't always see our global supply chains, which can feel really vague, and we don't necessarily see the data centers that are running carbon-intensive machine learning processes all day. But that doesn't mean we shouldn't think about them. As an individual contributor, it can feel easier to just kind of shrug my shoulders and say, like, I don't control what I build. It's not up to me. But I try to stay curious and skeptical when it's warranted. Should this feature really incorporate AI? Is this good for our users, or is this a shiny toy for our shareholders? I can create friction by asking these questions, by talking to my coworkers. I don't have a sledgehammer, but I have a brain and I have a voice. Thanks so much.